second year degree section. This is for mechanical and automobile engineering, and the subject is material technology. So in the earlier video we have completed up to question number 2A. Okay, so in this video we'll be doing question number 2B and further questions. So explain the property and microstructure changes occurring during cold working and recrystallization annealing of metal. So let us start. Here we have to see the properties and microstructure changes occurring during cold working and recrystallization annealing of metals. So as such, cold working is the process in which the metals or the alloys are heated below recrystallization temperature. So the effect of cold working is the hardness, tensile strength and internal stresses and electrical resistance increase, whereas the ductility and the corrosion resistance decreases. Annealing is the process in which the metal is heated at any suitable temperature for 1 hour and cooled it to room temperature. So here now we will be seeing the property, okay, and the structure changes during annealing heat treatment. It is like phases, it is recovery, recrystallization and grain growth. Okay, so here both cold working and annealing is plotted. Okay, so when we talk about property during cold working, as you can see, the properties, that is hardness, tensile strength, internal stress, electrical resistance increase, whereas the corrosion resistance and ductility decrease. And you can see the grain structure, how it looks. Okay, so during recovery phase, what happens and recrystallization and grain growth, let us see. First we will read out the theory regarding recovery, recrystallization and grain growth. During recovery, all the imperfection or the defects are eliminated completely from the metal. In recrystallization, nucleation is obtained and growth of new grains without phase change. Old distorted grains are replaced by the new stress-free, strain-free grain. Next is grain growth, that is small grains grow still smaller and are finally absorbed by the larger grain, which grow still larger. So now we will refer to the diagram. As you can see, cold working there is structural changes. Then during recovery, all the imperfection, okay, are removed. And if you can see, during crystallization, nucleation is taking place. Okay, so after that recrystallization, we will have stress free and strain free, okay, grains. Then in grain growth, the smaller grains are further becoming smaller, okay, so that it is absorbed by the larger grain and they further grow in size. So the grain size increases. So this was, and as you can see, the hardness, okay, as we go through the recrystallization phase, the hardness, tensile strength, internal stress, electrical resistance decreases, and when we go to the recrystallization phase, the corrosion resistance increases and ductility also increases. So now question number 3A. Okay, here I have not drawn the equilibrium diagram, that is Fe3C diagram, because that you must be already having and you must have already studied, but still if someone wants, please send comments or request. So question number 3A will also be solved or answered. Question number 3B, describe, okay, and one more thing which I have mentioned in my earlier video, that this is only few points. There are more points available in various textbooks that you can use, and also the points which I have written are very short. You have to elaborate during writing the answer, because these questions are for 5 to 10 marks, so you have to write more. Okay, like for example 5 marks you have to write around 1.5 page or 1 page. For 10 marks you have to write 2 or 2.5 page, depending on the content which you have to put, and also you have to draw diagram wherever applicable. So now Describe the cooling of 0.5% carbon steel to room temperature. Also find out the proportion of micro constituents in it at room temperature. The steel containing 0.5% carbon, as it is cooled below upper critical temperature, the iron begins to change the FCC structure, that is face centered, to BCC, that is body centered structure. Okay, so and the constituent are obtained during microstructure changes at room temperature are perlite and ferrite, 60% perlite and 40% ferrite. So this was question number 3b, and now let us go for question number 4a. What is fatigue of metals? Explain the method of testing the metal for fatigue. Discuss the various methods used to increase the fatigue life of a component. The maximum stress that a material can withstand without failure for a specific large number of cycles of stress is termed as its fatigue or endurance limit. Method of testing the metal for fatigue. Rotating beam fatigue test machine. As you can see over here, there is a motor, okay, for rotating, and there are bearings, okay, and the holder, and as you can see there is a test specimen, okay, and there is a revolution counter, okay, which reads the number of cycles. So the revolution counter reader provided with machine records the number of cycles applied, and when the specimen breaks, then the counter automatically disengages. So it counts the number of rotation, okay, or revolution of the test specimen before it breaks. Now regarding how to increase the fatigue life of the component, here I have mentioned two methods, but there are other methods also, and here I have mentioned only a short point. You have to elaborate. Corrosion. It reduces the number of cycles required to reach for every stress amplitude. Okay, here we can protect steel against salt corrosion by chromium or zinc plating. Surface finish, scratches, dent, identification marks can act as stress razor and reduce fatigue properties. Short pinning a surface produces surface compression residual stresses, and it will improve the fatigue performance. So these are only 2 points to increase the fatigue life of the component, but there are more points. Now question number 4b. What is hardenability and what are the factors affecting hardenability? Explain Jomini and quench test. Hardenability is the ability of the steel to develop its maximum hardness, that is depth of hardness, when subjected to normal hardening and quenching cycle. The factors which affects hardenability, there are various points I have mentioned here too. Alloying elements. In steel, alloying elements increases the hardenability. Severity of quench. Oil quenching increases hardenability as the cooling is slightly slower than with water or brine water. Now regarding Jomini and quench test. So here I have drawn the setup, how it looks like, but only a part of the setup. Okay, so here as you can see, there is a specimen which is heated to austenizing temperature and kept in the furnace for proper soaking time. This specimen, the diameter is 1 inch, okay, and the total length is 4 inch, and the orifice ID from where the water spray is coming is half an inch, and the distance between this water source and the specimen is half an inch. Okay, so the water is at 75 plus or minus 5 degree Fahrenheit. So then after the bar has been cooled, one band is ground from collar end up to the quench end and polished for proper hardness test. The hardness is measured on the Rockwell hardness tester with RC scale. So as you can see in the next here, this is the complete specimen, okay, and this is the on the left side the quenched end, and on the right side the collar end, and it is ground, and it is divided into 16 sections. Okay, so as you can see, 1/16th section, because the total length is 4 inch, which is divided into 16 sections. So 1/16 of the section, then 2/16 of the section, because at these places the hardness will be taken. Okay, and we can draw the hardenability curve. If we want to find, for example, 50 RC at what depth, okay, or from the the specimen, because it is cooled at the bottom, that is the quenched end. So from there, what length, okay, or the distance from the quenched end you can achieve a particular hardness. For example, 50 RC, if you want to check at what depth, okay, or the distance from the quenched end you have achieved this 50 RC, you can plot it, okay, and drop down, and you can find the distance from the quenched end where you have achieved this 50 RC. So this is hardenability curve.